Hey guys, Mrs. Stans here. So we're going to do a video for lesson 3 since I can't be here. So we're actually going to write the objective on the alternate lesson 3. So on page 23, if you can turn and write this objective. So we'll calculate a percent of increase or percent of decrease and see how it applies to exponential growth and decay. And your homework answers were in your mailbox. And let's go now to page 19 to do that do now. So we're studying how quickly the population of an invasive species of beetles will increase in a controlled farm setting. They calculate the population as increasing at a steady rate of 6% per week. At the beginning of the week, the population was 350 beetles. Find the population of beetles a week later by first finding 6% of 350 and adding it to the original. So a habit that I need you guys to get into is that when we find percent of a number, we really want to write this as a decimal. To change a percent to a decimal, we move the decimal point 2 places to the left. So this is really 0.06 times 350. That's how we can find 6% of 350. And we wind up getting 21. So this is how much it increased. So we have to add that 21 onto the original 350. And I guess there's 371 beetles 1 week later. And the reason why this really works is that we used 100% of the beetles to begin with. That's what the 350 is. That's all of the beetles. And then the 21 is actually 6% of the beetles, which means my final answer is really 106% of the population. And you did this in 7th grade, where you can learn to add these percentages together so that you don't have to first find a percent and then add it on. So on B, when it's asking you to do with the single multiplication, I want to take 106%, write it as a decimal, which is 1.06, and multiply it by that 350. And you'll see that you get the answer of 371 right away. So 1.06 times the 350 is 371. So when it asks, why does that work? It's because of what I showed you up here, that you're using 100% of the population and 6% of the population. Therefore, I want to just do 106% of the population. So what will the beetle population be after 2 weeks? So now 1 week has passed and there's 371 beetles. This is our new number that we have to use. And if it's going to continue to increase by 6% each week, now I want to take this and multiply it by the 1.06. And I get 393, I missed it, 0.26. Now we're talking about beetles. Do you really think there's 0.26 of a beetle? There's not. So we can say that the population is increasing by 6% each week, but of course we have to like maybe round some of our answers. There's about 393 beetles after the 2nd week. And now we're actually going to go to the alternate lesson 3. That alternate lesson 3 is on page 23. So some real life examples of growth rate in real life would be like compound interest. I told you like how bacteria grows. Sometimes we say population. There's plenty of other things. And decay. Half-life. I don't know if you've ever heard of half-life. Like, have you heard of carbon dating? Carbon dating is how we can figure out how old something is that we find when we dig it up, like fossils and things like that. I don't know, that's all I can really think of right now. We'll see as we go on. Maybe something else will come up that is about decay. But this is what we just talked about when we did the do now, that when it's growth, it's 100% plus the given percent. And when it's decay, it's 100% minus the given percent. And we always like it written as a decimal so that we can multiply things. So find the growth or decay rate for each situation and then solve for the exponential base. So if something is depreciating, that's like decay, that's going down. So we want to do 100%, take away 12%, gives me 88%. We like it as a decimal, so our base is going to be 0.88. A population increases at a rate of 32%, so 100% plus 32% is 132%, which written as a decimal, move it 2 places, is 1.32. So what we notice is that the base is between 0 and 1 for decay, and we've talked about that already, while the base is greater than 1 for growth. So number 3 is about interest. 100% plus 3% is 103%, which is 1.03 for your base. Amount of caffeine in your system decreases by 21% each hour. So 100% take away 21% is 79%, which is 0.79 for your base. Every round, half the tournament's participants are eliminated. So you have 100%, and it's going down by 50%. Therefore, you have 50%, which is 0.5 for your base. And this number 6 should have been on the other page, but the amount of bacteria is doubling every hour. So 200%. And this is what's important to me. Write equations of exponential growth and decay. So A is the initial amount. And B is called your growth factor. And remember, if B is greater than 1, it's going to grow. And if it's between 0 and 1, it's going to decay. So an exponential growth model for each situation has to be written. So you have to find your initial amount. You have to figure out what the growth factor is as a decimal. And then we're going to be writing the equation. So a $24,000 car depreciates, that means it's decaying, at a rate of 10% per year. So I'm going to think about 100%, take away 10% is 90%, which is 0.90 or 0.9 as your base. The car started at 24,000. So our equation, written in the form of y equals a times b to the x, is y equals 24,000 times 0.9 to the x. Number 8, the population of skunks in McHenry County started with 300 skunks and increases by 4% each month. So 100% plus 4% is 104%. Written as a decimal is 1.04. So the equation is y equals 300 times 1.04 to the x. A stock is valued at 300, that's the starting amount, and it decreases by 9%. So 100%, take away 9% is 91%, as the decimal is 0.91. So y equals 300 times 0.91 to the x power. Hopefully you're getting this. So we start with 124 teams. Half the competitors are eliminated. We just did a half question before. We said that's a 0.5. So the equation is y equals 124 times 0.5 to the x power. And doubling, we just did one like this before also. Doubling, we said, where'd it go, was 200%, which really is 2. So if it started at 2,000 and it doubles each year, the base is a 2, the equation would be y equals 2,000 times 2 to the x power. So I'll do number 12, and then I guess you guys are going to have to do the rest on your own and then finish up the lesson. So if you buy a car for $24,000, that's the starting amount, and it depreciates by 8% each year. 100%, take away 8% is 92%, which is 0.92. It says write an exponential function. Some of you left an answer like this on a test. This is not a function because I don't see an equal sign. So we have to write this as an equation. It doesn't tell us what to call our function. So I'll do f of x equals 24,000 times 0.92 to the x power. And we have to determine the value of a vehicle after 3 years. So you're going to plug in a 3 for x, because x represents the number of years. So really I'm trying to find f of 3. So you could use your calculator. So 24,000 parentheses 0.92 close parentheses to the, in place of x I'm going to put a 3 because I'm trying to find after 3 years. I get $18,688.51. Right, we write it as 2 decimal places because we're talking about money. Oops, I'm writing this in the wrong spot. Sorry. This next one is after 8 years, so substitute in an 8. Something I want to teach you on your calculator, instead of retyping in this 24,000 times 0.92 to the, and now 8th power, there's this thing called entry. It's on the enter button. You can see right above the enter button it says entry. If you do second function and then the enter button, it retypes what you just had. And now you could just use your arrow key, go back, and change this to an 8. It's just like a way of saving some keystrokes if you're interested. But I wind up getting $12,317.25 if we round it correctly. And I want you to work with your partner on 13 and 14, and then do your homework. Now your homework, let's go back for a moment. Please write this down. I want you to do lesson 3 on pages 26 and 27, and then also go back to page 22 and do 5 and 7. So if you could please write this down. And I'll see you soon. Have a good weekend.